welcome everyone to MLSecOps Connect, Ask the Experts. Thank you for joining us for this session today. My name is Charlie McCarthy. I'm the MLSecOps Community Leader, and today I have the honor of being joined by Red Team Director, hacker, and entrepreneur Johann Rehberger. Thank you so much for being here today.
Yeah, hi. Thanks so much for inviting me. Really excited to be here. Yeah.
Delighted. It's great to be talking with Johann again. We actually first introduced him to the MLSecOps community about 18 months ago when he agreed to appear as a guest on the MLSecOps podcast. And at that time, we were talking a lot about attacking machine learning systems and diving into some of Johann's Embrace the Red blog, which had a machine learning attack series that he's been working on for about 4 years at this point. Before we dive into questions from the community, Johann, would you mind giving the audience a little brief overview of your background and then maybe your journey from more traditional red teaming of like traditional software, quote unquote, to machine learning systems and what that transition looked like for you or where the interest was spurred?
Yeah, definitely. Yeah. Again, thanks so much for the intro. I'm really excited to be here. My journey started basically I was initially a software developer, then a software tester, and that brought me into security testing back then at Microsoft. And then I've been on that journey for a very long time, leading a penetration test team. Then at Microsoft moved to the cloud, we started red teaming, right, the infrastructure and so on. So I built out a red team at Microsoft Azure, in Azure Data. And that was a really exciting journey. And then I switched companies at one point to help build a red team at Uber. And then sort of at that point, I was like, I have done a lot in the red teaming space with penetration testing, right? Understanding the security impact, how to manage a red team. And sort of at that point, I realized there was this one thing I've never really looked at, which was machine learning. We had done at Microsoft back then, but there was Azure machine learning. But we looked mostly at this was like 10 years ago, at the infrastructure around it, right? Not really the models. And then so I got really interested in diving into taking a lot of courses from Andrew Ng and deep learning AI. And so just understanding the foundations of, what happens with these matrix multiplications.
Sure.
And then, I built out a model by myself and just put it around the infrastructure around it and put it out in the internet and then attack it myself. So really learn step by step. And what I found so fascinating is that a lot of the traditional knowledge just directly applied, just had different terminology. And so then I also realized there's this gap between the two worlds, and sort of really my work with the blog is really trying to bridge the academic research world and the experts that are like working within the models and train the models and build them to actually also connect them and to the traditional security world and vice versa. So that's really sort of, I see my spot in that middle ground a lot. Yeah.
Awesome. Okay, thank you. With that, let's dive right in, and we'll start with somewhat of a, dare I say, controversial question. This has been debated quite a bit within the MLSecOps community, but we are wanting to know how you define the term AI red teaming.
I kind of knew that question would come up.
Yeah, we have to start with that one.
I think there's two versions to the answer. The one is a very simple, fast, quick one. The other one is the long, debatable one, the philosophical one, I would even say. I think the simple one is very straightforward, maybe even like just a sentence. It's the idea of sort of a subfield of red teaming that focuses on the discovery, research, documentation, exploitation of techniques and procedures as they relate to machine learning systems or AI systems in general, right? And we do that in order to build better detections and mitigations. So that's sort of the simple answer. The long answer, that might I might go way off track, but so keep me in check. But I think the long answer is really, I think, what we see from just the term red teaming itself, right? Alternate analysis, it's even predates cybersecurity engineering and cybersecurity, right? So this idea of having an alternate perspective, bringing in different viewpoints to the table to attack or think about what could go wrong. So it's a lot about this what if kind of thinking. And that applies just throughout. So I'm actually totally okay that there is AI red teaming because it makes perfect sense to me. I know there's a controversy of the term. It's not really red teaming, but it is a fair point that red teaming evolves as well, right? And the understanding of what it means can evolve. Because I think as a red teamer myself, the big point is red teaming, the concept of red teaming itself should be constantly challenged because that's what red teaming itself is about, right? So it's sort of very fascinating things. There are maybe two aspects that are sometimes, or a couple of aspects that are sometimes missing in the machine learning or in the AI red teaming world, which is right now we are still in the very early stages where a lot of the what we call like AI red teaming might be what we would consider just assessments, or maybe more like vulnerability assessment, where we just run a set of tools with test cases and we get a result. Whereas red teaming really is more about objective driven. Like the model itself is just a little puzzle in a big adversarial scheme, right? And thinking that the systems level thinking, I think this is where a lot of it red teaming, or AI red teaming needs to focus on as well, right? That we don't forget that the model is just a little piece in a big adversarial puzzle potentially. Yeah, I can keep going on now for a while, talking about aspects that I think are interesting to know about red teaming, but I might go a little bit off track if we do that.
Yeah. I mean, why don't we double click on it a little bit? Yeah, if you don't mind speaking just a bit more, because like I said, this has been a topic that has come up frequently over the last several months, and I think
the real big thing about red teaming, and as I defined it every single time when I built the red team at a company, it is about finding, and the really important part is exploiting vulnerabilities, right? It's not just you find it, you identify it, and you show it. You demonstrate end-to-end impact. The thing is really about this impact piece, where you have a scenario, an adversary, what the adversary wants to achieve.
Right.
And that is really, I think, that system level thinking is really important when you think about red teaming. And in particular, I often see red teaming even within an organization. It's sort of like this emotional kind of spear, where you actually, a red team is a storytelling. It's telling you a story, how your company, how your organization, how your AI system got compromised, and what are the implications of that. Right? That's overarching story, I think, is really important when you do red teaming. And it drives organizational change because of that emotional aspect, right? It's not fun if you tell somebody, oh, I know your password, right? It's not, it's emotional, right? And this is really what red teaming can drive that change because of this being this emotional spear in a way. Yeah, and then when we think about particular AI red teaming or model red teaming, I think a lot about this concept called the Johari window, which sort of is of how people know themselves, or model or organizations might know the model, and how adversaries know the model. Like I'm applying that Johari window that is about personality to the security world. And there's like these aspects where, there's things both know. The adversary knows and you know. There are things that you know but about your model, but the adversary doesn't know. And then there are things that the adversary knows about your model, but you don't. And there's things that both don't know about the model, right? So red teaming should really be about this identifying this blind spot and what we don't know about the behavior of this model, right? Pushing the agenda forward, rather than just enumerating existing test cases and see how the model behaves with existing knowledge, right?
Okay.
Red teaming is there to push the envelope forward, research, figure out new attack vectors that we kind of don't know yet about. Yeah.
Right. When we think about cybersecurity and kind of the three major pillars, people, process, and technology or tools, you've talked a little bit about the people and the processes, and correct me if I'm hearing this incorrectly, but it sounds like some of the same people that are involved in this, so traditional red teamers, can apply some of their current processes, maybe adapt them to red teaming for AI, and maybe upskill a little bit. It's not like you need to bring on a whole new team of AI red teamers into an enterprise to be able to attack this problem. Is that fair?
I think there's a part of this that is 100% correct, which is I feel like traditional pen testers and red teamers actually have a very quick, easy path into this machine learning world, which is because all the underlying infrastructure, all the knowledge you possess already, all the knowledge you have about, how to laterally move through an environment, how to pivot from one machine to another to get to the machine that hosts the model, right? These are all things that are not really different. What is so unique about why the term AI red teaming is actually maybe even good in that sense, where there's an aspect that traditional pen testers or red teamers might not think about, which is the whole bias, safety, misinformation aspect, right? Mm-hmm. Where a lot of the research actually that happens within the model, right? That is also what I think a lot of, when we talk about AI red team, a lot of people consider just testing the model, right? These adversarial tests you do against the model. And that is really where we need the experts in that field to inform the security experts too, right? There's understanding really what is possible once you have a jailbreak or a prompt injection, right?
Right, and bridging the knowledge gaps to help the red teamers understand the security or the impacts of breaches or what have you. Yeah.
And I think the simple way for a traditional security person is actually that you just don't trust the model, right? Anybody tells you what comes back that you could trust it, is just not a good perspective. And this is why it's actually very simple for a red team or a penetration tester to interact, because it's just a cog in like a big system, but we cannot trust the output. And so we need to model our threat model according to that and put mitigations around the output that comes back from such a model.
Okay. There's one question here that just popped up in the chat related to AI red teaming. I'm going to ask that, and then we'll move down the list of pre-submitted questions because we have a lot to get to in this session.
Totally.
But this is a great question from Aryaman. Thank you. It says, how do you see AI red teaming product shaping up over time? There are way too many agentic AI capabilities that require manual human intervention to escalate the impact. Human-based red teaming versus automated red teaming is an interesting discussion.
Yeah, I think this is where a lot of red teamers would naturally object, because red teaming is fundamentally a process that I don't think you can automate. That is that you can automate some of the foundation, identify hotspots, but the real idea of red teaming is the storytelling, this creative process. And funny enough, actually, a machine learning model might be actually a good red teamer, and let me explain why. Because red teaming is there's like two ways of thinking in a broad way. There's linear thinkers, and then there's lateral thinkers. And most people possess both, of course, but red teamers are very good at that lateral thinking, which is you have random ideas that just are not making necessarily even like logical, consequential sense, right? Where you just from A to B, you're not thinking A to B, you sometimes think A, C, B. Right? And that is one of the things I think that is difficult to automate. So a lot of the tooling we see right now, I would often call it is more like a vulnerability assessment kind of tool.
Okay.
Yeah.
Fair. Thank you so much. Let's talk about LLMs. You and I, right before we went live, were talking about your machine learning attack series blog that has been going for, within your Embrace the Red blog, that series. And you said you'd been working on that for about 4 years and made the comment that, you know, we weren't really thinking about Gen AI then. And then we had this explosion of like ChatGPT in November 2022, and it changed everybody's world almost overnight. So this question from the community asks, how are large language models, LLMs, uniquely challenging to red teamers compared to conventional AI ML models? Are there specific red teaming strategies you'd recommend for LLMs?
That's a very good question. And I think it also highlights sort of this coming from predictive models where testing was a lot more straightforward, I think, versus the generative models where now we have this fundamental problem, which is the non-deterministic nature, right? Which I think this is what, when I do bug bounty hunting and I communicate with companies and talk about, this works, there's often like, what does this mean, right? And then the first time it doesn't repro, and then, you have to have a lot of conversations about, that the models get better, the repros will be better, and so on. And really understanding the fact that we cannot fundamentally reproduce the output the second time exactly the same way it happened the first time, right?
Right.
I think this is a challenge that, let me give you an example. Let's say you have a web application and the model is producing the output that is being displayed on that web application, right? The very, very natural thought is cross-site scripting. So now you need to come up with a prompt injection payload that will reflect back, or not reflect back, but that will output a cross-site scripting payload, right? And then we know some of the models have basic mitigations for that, where you then need some form of, I wouldn't necessarily call it jailbreak, some trickery that, allows you to output that text. But the fundamental knowledge, I think, is that we need to assume that the attacker can produce that output, because we do not know enough about these generative AI models to deterministically say, oh, they cannot ever create this output, right?
Right.
I hope that kind of covered the question.
It's perfect. Within the same vein, do you have any predictions, Johann, about how the threat of prompt injection will evolve as LLMs become more widely adopted?
Prompt injection is...
This is something that you've been exploring a lot.
Interesting and difficult, right? Because I think when I talk to various model vendors, I feel there's the understanding that it's not something that can actually be fundamentally mitigated or fixed. Let's say it can be mitigated, but not fixed, right? And in a way, I think there's actually a good way to think about prompt injection and how vendors think about it, I think, which is it's seen as an alignment problem. like a well-trained, well-behaved model would just never create a cross-site scripting payload, right? It would just not do it. And that is sort of this overarching alignment theme where there's just not a fix, and there probably will never be, at least not with the current architecture, where we can have a fix that is like for SQL injection. Just say, oh, do this one thing, and then you're going to be good.
Right.
And as model capabilities evolve, I think actually that this is sort of, I think about this a lot in my head. The experience I had so far is that whenever the models got better, the way to maybe initially trigger the prompt injection got a little bit more difficult. But once you pass that boundary, it's a lot easier and controllable what actually happens. And I think and believe that actually continues to be the case. That actually the better the models, the better the attack, and the more controlled the attack actually will become. Yeah.
Interesting. Okay, cool. These next couple questions are from John. Thank you, John. Since prompt filters don't work well on semantic attacks, or, oh man, y'all throwing terms in here that I did not read ahead of time, and I don't even know do you know how to pronounce this word?
Zero-day? Oh.
Epistemological attacks on models. Sorry, everybody. What are ways to deal with these types of zero-day threats?
I'm actually not fully understanding the question, since prompt filters don't work well on semantic attacks.
Some of these questions came in a little bit last minute, and so I'm throwing them at Johann like baseballs. But
I think I understand.
I'll read the second part of the question too. It's have you seen homoglyphs used in the wild or used homoglyphs in your research to test limits?
Yeah, I think this is a part where it's extremely difficult because the creativity of the attacker, right, on bypassing filters that are based on exact character matches. That you shouldn't output this one character, right? But for humans to understand that character, you can just produce another character that is very similar, and the human output you can actually just read it, right? If you have a filter for certain text that should not be outputted, right? It is pretty straightforward for the attacker to just output still the same text, but then have it just written in slightly different characters. Or
like maybe replace an S with a $sign or something.
That's a good example, right? And so there's all these capabilities with prompt injection, I think, will become more and more sophisticated over time. And to answer the second part of the question about the homoglyphs, that is actually a big part of what I'm looking at right now, is the trying to understand. This was a lot of that ASCII smuggling that I'll talk a little bit later, a little bit more, like where there's certain characters that models can interpret as being very similar to other characters. And so they can actually also understand things we tell them that bypass filters on the way in. So if you ask a question in a certain Unicode style with a certain Unicode font in a way, or with emojis, right, they can easily bypass filters, but the model will actually understand those. And that is the really tricky part about any sort of firewalling, that an attacker can still get the data through. Yeah.
Okay. Thank you again, John, for those questions. Sorry, I butchered the first one. Moving on. Have you noticed, Johann, any advancements in adversarial attacks recently? If so, how might we better prepare for them?
I think that actually, now speaking from my personal research, that the idea of these characters, and one very recent example that I like pointing out is that Riley Goodside identified in January, right, that machine learning models, or back then he pointed out ChatGPT, can interpret hidden characters, right? There's this Unicode standard called the Unicode tags block. And within that block of I think 255 characters probably, or code points, you can mirror the entire ASCII set, the ASCII character set, which means you have an alphabet you can communicate with.
Okay.
And turns out that the language model, when you send in these invisible characters, so you don't see them in the UI, the language model actually fully understands what you're talking about. So you can sneak in data. And then further research that I kind of focused on then was, can the language models also produce these hidden code points, Unicode code points? So that the way out, the language model creates text, it says hello, but then it appends more data, and the humans, we don't see it, but it is actually in the text. So if you copy paste that and put it somewhere else, you're actually copying more out of the application than you realize.
Oh, wow.
And these are really fascinating attacks, I think, where first, we identified this one place where there's this hidden capability that I call it hidden feature of a language model, right? That now everybody needs to act on and figure out how we can mitigate this. Because I actually created a full exploit chain with Microsoft Copilot, where Copilot was actually rendering a link, and then within that link, it would the attacker would have Copilot insert hidden characters that actually was exfiltrating data. So when the link was rendered in the UI and the user would click the link, the user would think, oh, I'm just visiting this website, the homepage of that company, for instance. But in reality, clicking that link also sent all that data off to that company at that same time.
Right.
So there's just a fundamental leakage problem that models might leak data by accident. But then there's also the adversarial aspect that attackers can actually trigger this behavior on purpose. Right. And so I find these attacks super interesting because they're quite novel, and they become so powerful because the model is actually capable of doing these things. Yeah.
Okay, thank you. Next question from the community. How would you comparatively view the frequency of tests against models as opposed to the surrounding systems? For example, RAG architectures, retrieval augmented generation architectures.
So my focus is primarily on the system level thinking as a red teamer. So I usually think the model, I know this sounds maybe strange, but I know I cannot trust the output. I know I can make it produce whatever I want, right? This is sort of the thinking I have in my head. And it might take a while to find a bypass or something, but I think most of the time you can, so far it has always been the case. You can produce whatever output you want. So I go in with that thinking. So for me, any attacks around RAG are really, really interesting because of that, right? Because that's the aspect where you get your prompt injection into the system that then takes control of the output of the language model. I focus a lot on the RAG capabilities and the tooling integration of language models, where we give developers or companies give the language model agency, because at that point it becomes really interesting from a security point of view, because then the model might be doing things and might have. It's very common, and everybody talks about human in the loop, but I very rarely see that actually really being implemented by companies, especially companies that also talk a lot about safety and security. Human in the loop is not really something that is being done. It's just tool invocation after tool invocation. You can call automatic image generation, right? That can lead to data exfiltration by itself. You would create an image, right? You can invoke web browsing, right? That also leaks data out to somebody else, right? You can invoke, memory tools. That's like a recent research I did, is like invoking the memory tool to actually persist instructions for the future. So the RAG integrations, and not just RAG, I think actually generally the tooling aspect is really where a lot of vulnerabilities are introduced into the systems. Yeah.
Okay. Follow-up question that was not pre-submitted. This one just came in from the chat from Chris. Thank you. What percentage of customers have you seen, if any, with at least LLM and RAG security?
Security issues or?
Feel welcome to clarify, Chris, in the chat, but just...
probably security vulnerabilities. I think looking at I'm mostly speaking here from my bug bounty experience working with vendors, right? I think when, as soon as the companies start integrating RAG, you see prompt injection being a real problem at that point, because attackers can control the data. And then there's a lot of struggle around what is acceptable. And this is actually really, security is always about risk management. This is like a big thing also for prompt injection, right? It's about managing the risk. What is acceptable to your company? What is acceptable to that particular company that introduces the language model, right? If you look, for instance, Amazon has this system called Rufus, like Expedia has also a chatbot. They seem to be totally fine that you can use that chatbot to do arbitrary things not related to searching the Amazon catalog, right? And that's a business decision. They say, oh, we don't care if you jailbreak and have it output a choke or use it to write your source code, right? It's they accept that risk. And other companies might have more brand protection concerns, saying, I don't want to have the chatbot output like a choke, an inappropriate choke or source code, because I want it to operate just in the bounds of what it's supposed to be doing. So there's a lot of trade-offs, I think. And every company is like trying to figure that out, I think, to what is acceptable and what not.
Right. And they're assessing risk in different areas like financial risk, reputational,
and there is obviously also this big difference between, is it a public facing application, a chatbot, right? Or is it an internal system? Because I believe a lot of companies internally, the systems are a lot more capable, a lot less guardrails in place, because, the trust boundary is slightly different, and you don't get like if you have a jailbreak, right, it's very common. Somebody does a jailbreak, which is and then post it on Twitter, right, and then it gets a lot of attention. And some companies don't mind that. Some companies would not want that to happen, depending on also what the company's purpose or mission is in a way. Yeah.
Right. And kind of coming back around to the point you made at the beginning, impact. So like, what is your risk tolerance? What's the impact of this on your business? That sort of thing.
Yeah.
Lots of considerations. This next question is a little bit general, and you've spoken to it a bit already, Johann, regarding vulnerabilities that you have found or seen that other people found in AI ML systems. Are there any that you would describe as being the most common types of vulnerabilities?
Surprise people. Of course, if you talk about AI specifically, I think prompt injection is just because it's just by design, right?
Yeah.
But lack of authentication, clear text credentials that allow you to access AI systems, right? It's actually the traditional security problems that are just fast forwarded into this new realm of AI systems, right? Where you find a key and you use the key and you just talk to the system, right? Actually, a very good example, Microsoft has something called the Microsoft Copilot Studio,
right,
which is a chatbot creation framework. So it used to be called Power Virtual Agents. So it allows you to create a chatbot rather quickly. It was introduced 4 or 5 years ago. And so it was rebranded to Microsoft Copilot Studio. So you now can create a Copilot. So with generative AI, that was kind of added as a feature. And turns out that anybody in an organization can create such a Copilot, and you can publish it, make it available to other users in your company, right? To talk about, the finance data or the HR, the address book, and so on. But it turns out that the creator of a Copilot can publish it on the internet to the world. And that, of course, very few companies have even that insight that this feature, this system exists, but are not even knowing that people use it and create it. And there's no off by default or data leak prevention policies that Microsoft had put in place. So I think a lot of that is being changed now, but these are these typical examples where just not having authorization at all, right? And just call it and get the data back, right? I think these traditional problems are very common and especially difficult. And I call this actually the data access proliferation problem, where it's very straightforward to build a chatbot, just a few lines of Python code. But in order for it to have a lot of value, you need to give it the access to data. So I think what we are seeing now is this extreme data access proliferation where chatbots just want to have access to all the data to be useful. And developers in companies just want to do that, right? They want connected to this system, connected to that system. But it's very easy to build a powerful application and that has access to a lot of data. But then do you think about, trusted subsystem problems where, the user A calls in, should they be able to do an enterprise search that impersonates a powerful account to retrieve more data than the user can actually see, right? There's a lot of problems that are getting automatically introduced by moving too fast, too quickly in that space without proper threat modeling and so on. Yeah.
Okay, got it. Another question from the chat just now. I'll move this over so you can see. This is from Bailey. What is the perspective of AI practitioners with respect to actually feared attack vectors? To which extent research AI/ML is far from actual field attacks viewed by AI practitioners, example, designers, integrators, users? I'm not quite following, but...
Respect to actually feared. I think this is I'm not fully getting the question, I think, as well, but to which extent research... I think this is it's a very interesting question. So the question, I believe, I'm paraphrasing now the way I understand it.
Yes.
Is, what we see in the real world, the exploits we see in the real world, how much of this is actually being discovered in research, or how much is research ahead of what we see in the real world, or the correlation between the two? I think that's where the question gets to.
Yeah.
And this, I think the research, the problem a lot with research is often that it's narrow focused on it's not a problem, actually. It's very incorrect what I said. The focus in research is very specific scenarios, right? Research one element to actually contribute to the overall knowledge for everybody in the world, right? So research is the core foundation for a lot of these things. And real world attackers, right? They have this, they don't think about just one specific thing. They have this overarching look, like they have a goal, right? They want to steal money. They want to ransom a company, right? And they might use some of these pieces to achieve the overall goal. So we haven't really seen a whole lot of attacks where adversaries use, and that is actually fundamentally changing right now, right? Where adversaries use AI and ML to produce phishing emails automatically, right? You just translate it. The user speaks German, make it German. When the user speaks English, make it English. Chinese, make it Chinese, right? All these attack capabilities that are being created right now, I think will really challenge us all in the future, and we will live, and this is, I think, very important to grasp, and that's also why funny that my embrace the red block sort of intrinsically kind of highlights that. I think we will live in a world where you cannot trust anything, right? Even now, like everything you see online,
What you see, what you hear,
real, right?
yeah.
So there is a fundamental challenge that we all need to think about, and the hope research is going into this very deep. How can you authenticate content that you know this is actually really from that person? That you can trust the system that this is from that person. So we're moving into this embracing the red, right? It's like you need to realize that this is actually happening right now. That
shift your mindset.
Yeah. So that's very fascinating to think through.
Yes. Okay, shifting gears a bit. This next question asks, in your experience, how frequently, this is about transferability, how frequently do attacks designed for one machine learning model successfully transfer to other models within the same environment, would you say?
Yeah, so when I put the disclaimer out, right, I'm not like a academic machine learning researcher, right, that researches this particular topic in detail with metrics and statistics.
Yes.
But just purely from my point of view, if I create a prompt injection that works with one model, or like, let's take the ASCII smuggling example, right? Turns out that this feature, this capability actually exists pretty much in all language models. So they all have been trained with a sort of the same amount of data, and they all learned about these Unicode tag characters. So they all possess the capability. And so an attacker just needs to extract that feature and then use it to their advantage. So in many ways, I think a lot of these attacks do translate quite well between models and systems. Yeah.
Okay. Thank you. This one is pretty straightforward, but I don't have additional context for it, so I hope you know what it means, but it just asks, what kind of assessments have you already done?
Oh, yeah, that's a really broad question. I was not sure how to answer that. I remember seeing that. I've done, as a red teamer, right? I've done, I think, a lot of very interesting projects. I back in previous companies I worked at, we did like cryptocurrency mining projects where we would like compromise as many computers as possible to mine cryptocurrency as a kind of adversarial simulation. Privacy focused assessments, but I believe the question is really more about AI and machine learning ones.
Right.
I think assessments that go around traditional security aspects, and I think every company should do that, is like two things. Compromise a model, backdoor it, like not going out there as a red team exercise that is authorized and approved by the organization.
Right, of course.
Compromise a model and need to put that disclaimer out, right?
Yeah.
Compromise a model, put a backdoor in, and then have that be an attack vector to infiltrate the company or to kind of get remote code execution on computers. That is one aspect, I think, that really there has to be a lot more understanding, and that the machine learning model in many ways is just like an executable. The developer loading it, the data scientist loading it up on their computer, it's like running an EXE in many cases, right? There's improvements on how the model formats work, but there's still a lot of models out there that's like a pickle formats and so on. That is a really critical operation. The other one is then actually going ahead and just backdooring a model or replacing a model. I think it's like these very traditional cybersecurity aspects. I think this is something that because I often get that question from pen testers and red teamers, like, how do you do AI testing? And I think this is where you start. You just take what you know and then translate that to the AI world. I think that's a very good start from the traditional security world into the AI world, to just start exploring how can you replace a model? How is the model secured? Where do people load the model from, right? Because the model itself is very capable and powerful. Yeah.
Yeah. I like that point you made. Just start with what you know.
Yeah.
Yeah. Are there any monitoring strategies that you would recommend? And do you think it's possible to have a reliable real-time monitoring strategy at a reasonable cost?
Yeah. I need to dissect the question between generic security engineering, because I think this is actually one of the challenges a lot of people in the industry have. You want to monitor everything to have that overarching insight what happens in systems, but it can be very expensive to monitor like everything, right? So most companies have sort of this idea of you monitor for like a certain amount of days, and then you roll forward what you actually see, but keep that certain number of days so you can actually see adversarial movement and like lateral movement throughout an environment, right? If an adversary pivots once a week between one machine to another, right, and you don't have logs that spawn like 8-9 days, you might actually not really ever capture that objective of the adversary, like from where they are moving from, where they're moving to, right? And that also kind of applies similar to machine learning, right? I think one aspect that is often overlooked is like, should you log the prompts or not? Like what the user is typing in, what comes back, right? That's a really good question. And I think in many ways, it's actually logged automatically. A lot of people don't realize that. I think if you have like a Slack bot that is integrated with LLMs, right? It's just in Slack itself, you have that basically locked for the future. But I think this is really for every company to think through is, the login of the prompt. What would happen if the model all of a sudden spits out internal data and that is leaked, right? If you don't have the prompt, the response, you would never know even what triggered it, what caused it, right? There's some aspect that really has to be explored. And then on the other hand, of course, you need to protect the privacy and to mitigate the risk of this information leaking, but as with any other security logging, right? So having just like a certain amount of days that information is present and it's encrypted, of course, and so on. I think those are a lot of strategies for monitoring that can help.
Okay, thank you. And thank you for the questions. These are great. Johann, how do you feel about assessing AI risks, models and systems, with existing methods like CVSS?
That is a really good question. I like this question a lot because when I started my journey in the basically Gen AI hacking, whenever I reached out to companies about a problem I found, I never sort of reported often as just prompt injection in general. It was always something that I believe had security impact. And I always actually went ahead to describe the vulnerability with a CVSS score. And then I think that surprised many. And many, like even bug bounty programs, they initially weren't able to pass what I was actually saying. But it's actually, it's not ideal, but I think a lot of aspects, you can actually give it a CVSS score. The problem with CVSS itself, it misses like the context of the exploit or the vulnerability. So if something is critical, it does actually not mean it's critical to you, to your company, right? It just means in this aspect, it's seen as critical, but it might, even if you have it in your company, it might not impact you at all, depending on the context where the component that is vulnerable exists. But I have this example, for instance, with the data exfiltration with URLs, right? You can really give this a CVSS score very simply. It's a remote attack, right? You just go through the list. It's a remote attack, no interaction required, right? Because the user visits, they want to analyze the PDF document. They want to analyze the website. So it's a feature. It's not that there's user interaction required to trigger that condition. It's just the question is then is user interaction required to click a link, or is an image rendered, which is then there's no user interaction required, right? So you go through the list and it comes to the core piece of the question, which is confidentiality, integrity, and availability. And it turns out that prompt injection can impact all three of them. We know integrity is fundamentally lost as soon as you put data into a language model. Like you cannot trust what comes out. Confidentiality, we demonstrated now with if an application renders hyperlinks or images, confidentiality is lost. And then availability is also interesting because you cannot build a system where the language model itself is a core bottleneck sort of system, because an adversary can always DOS it. It can just say, oh, follow these instructions, just reply, I'm not available right now or something, right? So that's like really, really fascinating. So I think there's value, but there's just an overarching problem with CVSS, which is it misses the context of the problem for a company. And I think that's not just unique for AI, but it's actually beyond AI even.
Okay. Thank you. There was we interviewed a guest for the podcast recently who made another interesting comment kind of related to that. It's just that we need maybe more standardization as we're so early in thinking about AI vulnerabilities in those terms. So just an interesting afternote there. Okay, we are at our 5-minute warning here. I want to throw in this question from the chat and then try to get to maybe one more from the pre-submitted questions. Resources related to concepts that Johann has mentioned, or even links to his blog that we've mentioned, these will all be included in the show notes when we release this video on demand next week. So this question from the chat, Johann says, in security, firewalls have been known to have lots of false alarms. How do you see the AI guardrails firewall working in the case of modern day agentic AI applications where the real attacks are actually chained rather than a single point prompt injection?
Firewalling in the concept of, or guardrailing, right, in the concept of machine learning models, sort of the current, I think that is the mitigation we are putting in place for the consequences of a prompt injection, or the consequence. Actually, this is an important aspect that I wanted to actually throw into one of the answers to my questions. I always want to highlight this, that the model might even do something malicious without a prompt injection, right? This is, I think, often misunderstood because we do not know what happens in these models. There's a backdoor that maybe when this certain condition happens, it will do this certain thing, right? So even if there's no prompt injection, you cannot trust the output. And that sort of comes to the firewall guardrailing concept, right? That you can steer the output, you can make it more robust, but the fundamental understanding always has to be, right, that in a high consequence system where there's a decision being made that is very critical, like updating. I don't want to give example because there's different companies have different thresholds. But updating database records, sending an email, could be in the military, right? Deciding certain things in these high consequence decision making process. You cannot trust. You have to have something more than just like when this string occurs, don't do that, or that is, I think, the fundamental challenge that we are facing. That when we design a system, even with guardrails in place, you always need to assume that all of that can be bypassed because it probably can. And so that's, again, the risk decision. Right? But guardrails are really good to have a chatbot that is not like going off the rails crazy or does something really inappropriate, right? But if there's an attacker in the loop, that is when a lot of things really start breaking down.
Okay, thank you. All right, last question. I see a couple more coming in, y'all. I'm sorry we didn't have time to get to them today. This has been a very popular session. And again, Johann, thank you so much for being here to share your insights with the community. I love this last question because it plays into the theme of the community, which is knowledge sharing and helping others upskill and grow and learn more about this space. So it asks, what are some resources that you have used to progress in this field? Anything you could share with the audience?
Yeah, definitely. For machine learning, I think there's really good content out there. I learned a lot from going through the initial Coursera course from Andrew and just understanding how it all works in the model itself with matrix multiplication, right? With what all these terms actually mean, like regularization and all these terms, you kind of get that understanding. So there's now better courses from Andrew or his company, Deep Learning AI. So I always really recommend that content. Deep Learning AI, I like a lot. There is learn prompting. I always like that, pointing that out too. I know you had
Sander, yeah.
a few weeks ago, I think.
Yep.
But learn prompting is actually really good because they always try to stay up to date with the latest information, with the latest examples and so on. So that's a really good resource. So yeah, I think there is a lot of really good content out there, but those would be like the some of the core. I'm actually now probably forgetting a lot, but that's those some of. Oh, of course, my blog. Yeah.
Embrace the red.
Just kidding. Yeah.
Yes.
But there is a lot of good content out there that is free actually too.
Yes.
Yeah.
Awesome. Okay. Thank you so much.
Yeah.
If y'all have follow-up questions for Johann, he is a very busy professional, but he is part of the MLSecOps community. And so you might consider sending some of those to him personally. And as time allows, may be able to get to a couple of those. You'll be able to find this video on demand next week at community.mlsecops.com. Again, we'll link to resources, including the ones you just mentioned for learning and Johann's blog. And thanks so much again for being here. Hopefully we get to talk to you again soon.
Thank you very much. And thanks for all the questions. Bye-bye.
Thanks, everybody.